All right, the chain rule. What does it say? If I have a composition of functions, right, it should be pretty clear to tell what's inside and what's outside, right? So the function that's outside is the function f. The function that's inside is the function g. And when I'm finding my derivative here, I'm going to have f prime of g all times g prime. So pretty clear derivative of the outside function, right? With g still inside, yes? And that with the product of the derivative of the g, right, of that inside function. We could use a loop, f prime, g prime. I want g inside of f prime. Do you see that? So inside of the f prime function is the function g. Keep the cat in the box, and then multiply by g prime, right? So let's look at a quick function here. Let's do y equals e to the 2x. What's the outside function? E to the x, yep. E to the x. What's its derivative? E to the x. What's the inside function? 2x. What's its derivative? 2. So I'm going to take, right, I'm going to use that loop. I have to put that 2x into my derivative function, right? So I have e to the 2x times another 2. Pretty simple, huh? Oh my God, nothing's... Let's try another one. Y equals sine of pi x. Thanks, homework. Perfect. What's the outside function? Sine. What's the derivative of sine? So cosine of pi x, right? The derivative of sine is cosine. Make sure I evaluate at the same place. Keep the cat in the box. Times the derivative of the inside. What's the derivative of the inside? Pi. Here it is. Y equals square root of 1 minus 2x. We had that one on one of our quizzes. What's the outside function? Square root function, right? I know what the derivative of square root function is. I have it memorized. 1 over 2 square roots. What was ever inside stays inside. And then I multiply it by the derivative of the inside. What is the derivative of the inside? Negative 2. And then I simplify. So negative 1 over square roots of 1 minus 2x. Chain rule. Pretty damn simple, right? Yes. X e to the negative x. Now we have a product. So we have to use the product rule. And we have always to use the chain rule. Right? What's my first function? In the product, what's the first function? Yep. What's its derivative? Good. Second function is e to the negative x. What's its derivative? E to the negative x times negative 1. Right? Derivative of the inside is negative 1. Oops, product rule. Oh yeah, product rule. Right? So I have negative x e to the negative x plus e to the negative x. I'm going to factor out the e to the negative x times 1 minus x. Yeah, so the derivative, yep. So the inside function is negative x, agreed? And what's the slope of negative x? Negative 1. Yep. Mm-hmm. So I could bring the negative out. I certainly could do that. Y prime is negative e to the negative x, and then I have an x minus 1. But yeah, I wouldn't mark either of those wrong. I like to, whenever I can, I'm trying to save, it's from a computer science standpoint, trying to save characters. So in this one, right, in this one I have one less character to write. Let's see, y equals sine squared of 2x. What's the inside function? Sine 2x. What's the outside function? It's something squared, right? So that's what I really have there. Yeah, question? It's like, how do you know what's a cat or a dog? Yeah, I get it, but it's just like I just got to show you a bunch until you kind of figure it out. No one told you what a cat or a dog is. You just saw a bunch. Say again. This is a nested one. Yep. So first of all, do you see that the square is the outside function? That's what I really want you to see, right? And so then if you look at the inside function, notice there's an inside of the inside, right? So you're not wrong saying that there is an inside function of 2x, but it's not the one I want to deal with first. So y prime is 2 times the sine of 2x. Now to the first power, because I took a power down, right? Now I'm doing the derivative of the inside function. So that's a prime, right? This is a 1, right? The other is a prime symbol. So how do I take the derivative of that? Well, derivative of the outside function now is cosine. Still have the 2x, still have the mouse inside of the cat. Then times what? Yep, times another 2. So I get 2 times the sine of 4x. Those are strange, right? It's identity. 2 times sine theta cos theta is sine of double the angle, right? Let's do another nested one. What's the I kind of want to cheat on this one, don't I? Just take a square root first, right? So what's the outside function? Square roots, right? Yes? So y prime is 1 over 2 square roots of keep the cat in the box. And then what is the derivative of the inside? Well, that's another chain rule, isn't it? What's the derivative of the inside? So, well, the inside function is e to the x squared, but we want prime, right? Everybody with me? Good. How do I do that? Okay, so the derivative of an e to the anything is e to the anything. So I still have e to the x squared, right? But I need also the derivative of that inside, which is? Yep. And then my 2's cancel. And my e to the x squared cancels, so I just get x over, oh no. I get x square root of e to the x squared. I wonder, can I do anything with that? Well, e to the x squared raised to the half power, right? That's the only thing I could do. And what does that half power become? What do you do with exponents when you're raising an exponent to an exponent? Just multiply them. Multiply the exponents, right? Yep. Where you at? I don't typically give a lot of nested chain rule problems. Okay? So I don't typically give a lot of nested chain rule problems, meaning I don't give any. If you look at the last 2 tests, I don't think there were any on there. Yeah, so if you agree, um, it's easier to look at this version. Uh, um, a over square root of a is rad a times rad a over rad a. So just rad a. So I had, right, I've got this guy is 2 of these. So I could have written this as square root of e to the x squared times another square root of e to the x squared times 2x over 2 times square root of e to the x squared, and that's where one of them canceled. And the 2's canceled. All right, let's do one from the book. Let's do 30. I'm going to change it to x's. So if f of x is the square root of x over x squared plus 4. So I clearly have a fraction, right? So I'm definitely going to use quotient rule. I have to also make sure I'm doing the chain rule. But this is almost, it's quick to start, but it's slow to finish. I have a square root function as the outside, clear, right? It's clear, I have a square root function on the outside, yeah? So, and I know the derivative of that, right? I know the derivative of that, and I'm going to make sure I keep whatever was inside, inside. And then I just have to do the derivative of the inside, and I'm put a placeholder on, right? Saying, hey, that's me taking the derivative of the inside. Now that piece I have to do with the quotient rule. Top function is x. Don't let me lose you here. You should be writing with me. Derivative of x. Thank you. Downstairs function is x squared plus 4. Derivative of that, 2x plus 0. Nice. And I have to also make sure I grab that downstairs squared. Not going to FOIL it out. I want things factored. I'm ready to go back to f prime. I still have my 1 over 2 square roots of whatever was inside. Times my quotient rule piece, which is x squared plus 4 minus 2x squared, all over x squared plus 4 quantity squared. Everybody with me? Anybody not with me? Everybody's with me. So I can simplify this. Right? In the quotient rule, it does. Has to be this one first. And why does it matter? Because of the negative in between. Yep. Yep. So upstairs, what do I have? I have a 4 minus x squared. I've got a 2 square roots of x and a square root of x squared plus 4, and then another x squared plus 4 quantity squared. So there's my square root of x, right? And this is also square root of x squared plus 4. And why did I do that? Because I can simplify this, right? I could cancel this into, so 3 halves. So 4 minus x squared, 2 times x squared plus 4 to the 3 halves power times the square root of x. You will make a lot of, you won't bring the algebra all the way to where the book wants it. And so you just got to get used to that. Is everyone okay with that algebra there? Say again? I have an x squared minus 2x squared. Right? So the 4 is still positive. Yep. Yeah. Yep. Yeah, so because this guy, this is really me having x squared plus 4. Yeah, 2 minus a half, right? Because I have this, right? And so 2 minus a half is 4 halves minus 1 half, so it's 3 halves. When you have like bases and you're dividing them, you subtract them, the exponents. Like bases, right? Dividing them, subtract exponents. Uh, yes. Yeah. Yeah. The square root is 1 half power, right? So then I have a 2 minus 1 half, that's 3 halves. Let's do another one. Sorry. Let's do number 33. Hmm. 3.7, number 33. It says use logs. We're not going to use logs yet, but I have 2x plus 1 to the 5th times an x to the 4th minus 3 all to the 6th. So definitely a product rule, right? And always a chain rule. Always, always, always a chain rule. So my first function in the product is 2x plus 1 to the 5th. What's that derivative? Nice, times another 2, right? Derivative of the inside. Second function in the product is x to the 4th minus 3, all quantity to the 6th. Derivative is 6 times x to the 4th minus 3, now to the 5th power, times another what? 4x cubed. Everybody with me? Product rule. So y prime, I'm going to gather up these terms first. So it looks like 24x cubed times 2x plus 1 to the 5th times x to the 4th minus 3 all to the 5th. Everyone agree? Plus 10 times 2x plus 1 to the 4th times an x to the 4th minus 3 all to the 6th. I'm looking to see what can I take out, right? What's shared that I can take out, right? You see I've got them grouped similarly, right? So out of the single underline, I can take out a 2, correct? 24, 2 goes into 24, 2 goes into 10, correct? Good. How many 2x plus 1s can I take out? I have to take out the smaller power, so I could take out 4 of them. And then how many x to the 4th minus 3, how many of those factors can I take out? 5. Right, because I've look at my triple underline. I have 5, 1 power is 5, 1 power is 6. So I can take out 5. What's left over? (12x cubed) times a 2x plus 1 plus 5 times an x to the 4 minus 3. Everybody agree? Anyone in disagreement? I want to finish that set of square parens up, see what happens. And it looks like I get 24x to the 4th plus 12x cubed plus 5x to the 4th minus 15. (29x to the 4th plus 12x cubed minus 15. Yuck. I'm hoping that piece is not factorable, because I don't really feel like dealing with the horrible coefficients. But one way I could look and see if it's factorable or not is by graphing it, right? So I'm going to graph that one piece. Damn it. Well, there are definitely 2 roots. What? It hits roots. It might not be factorable. They might be irrational roots. In fact, they look like they're irrational roots, but I'm not going to give you something that's this ugly. I can't factor that. It could possibly have roots. Remember from pre-cal? It could possibly have roots of plus or minus 1, 3, 5, 15 over 29 is prime, right? So it could have a root of 1 over 29, 3 over 29, 5 over 29, or 15 over 29. Yuck. So anyway, we're going to keep it there. Yep. I mean, I could do it with the quotient rule by just moving one factor down. It doesn't change it at all. You could definitely do that one we did last class with the quotient rule. What was it? Let me give you another one. Let's have you do one. I'll shut up. I'll try to anyway. No, this is where I'm going. I'm going to look at test 2, the chapter 2 test from last semester. And that's right in the announcements. All my tests from last semester are in the announcements. Right? So I'm going into the class, into the announcements, down to test 2. What? I didn't. Oh, I need test 3. Sorry. Yeah, that's just chapter 2. You're going to have a chapter 2, chapter 3 together. I haven't decided yet. Here is number 2. Chapter 3 test. It's right there on the screen if you don't want to look for it. Chapter 3 test solutions, right? Problem number 2. Yep. Yeah, always. Yeah, it's a product rule, but it's always a chain rule. Yeah, we do.